As you might imagine, there are a huge number of functions that can be used with data frames in BaseR and by installing additional packages. But let's take a look at a few of the most common functions that we can use with data frames. Like matrices, data frames can be transposed. So here's my data. And here's the transpose of my data, in which we see that each of the columns have been turned into rows. The names for the rows are now the names for the columns, and vice versa. The aggregate function allows you to apply a function to subsets in your data frame. Let's look at mean scores for males and females. So look what I'm doing here. I'm subsetting out score and age from my data. That's what you're getting right here. Then I'm giving that as the first argument for the aggregate function. So subsetting out what columns I want is the first argument for the aggregate function. Then I have a by argument in which I need to use a list to list out all the different categorical variables that I want to group on when I get my aggregate function for score and age. And then finally, in the fun argument, we get the function that we want to use. So these are the data that we're going to aggregate on, score and age. This is the grouping variable, and it has to be in a list. And then this is the function mean. And there we have it. We have our female score and age means and our male score and age means. Note that aggregate works on data frames and returns a data frame. So if I store these and then look at the class, it's a data frame. So what we're seeing in this little table is itself a data frame, which means that you could now take out, using subsetting functions, any of the elements that you need for this for both statistical analysis and reporting. Now, could I have just gone ahead and done the mean function on everyone in the data set? Notice here on my data, I'm not subsetting. Well, yes and no. Keep in mind that my data contains, if we look at it down here in our environment, an integer, and then it contains the character, a number, another character, a number. So think about getting means on characters. Something's funny going on there. So could you do this and will it work? Yes, it will work, but you're going to get messiness. You're going to get a lot of warning messages about things that are not numbers. Let's use the HSV2 data for a more complex example. So here I'm going to do read CSV and read in the HSV2. Let's obtain test score means by both gender and type of school. So again, I am going to select out, using subsetting and the sequence operator, the 7th through 11th vectors, which happen to be the scores in the data set. If we look at HSV2, 1, 2, 3, 4, 5, 6, 7 is reading score through 11, which is social studies score. I'm again going to use a list, but this time notice I'm using 2 of my variables in the list, 2 variables that I can group by. Female, which is as an integer right now because we didn't make it a factor. We should probably make that a factor. And then school type, again, we should make that a factor. And then put these in the list and then do the mean function. Now what you're seeing are the codes indicating whether it's female, male, the codes indicating whether it's public or private schools. If we had factors, these would be nice names here. And then we have the mean for each of those types of test, each element of the testing. Now, we don't have to do this just for means. We could do this for, say, 5-number summary. Notice I've replaced the function here to be now 5-number. And as you might imagine, this is going to give me a bunch of stuff. Let me open a nice wide window. And here you have it. So now you have the reading 5-number summary in 5 columns for reading, and then similarly for writing and so forth. And of course, we'd want to give these better names to indicate that we're getting minimum, first quartile, median, third quartile, and maximum. The apply function will apply another function provided as an argument to the data frame. So here, I'm using the HSV2 data. We'll talk about this too in a moment. And we're applying median as an argument. So let's see what we get. What we get when we do that is we get the median of all the values in the data set. Now, some of these doesn't make a lot of sense because we're dealing with whether it's female, male. But here we see the medians for all the variables in our data set. The apply function, instead of returning a data frame like the aggregate did, let's see what it returns. It returns a numeric, so it's giving a vector. So if you want this in a vector, even though aggregate and apply will give you the same things, if you want it in a vector instead of a data frame, you can get a nice vector of medians in this case by using the apply function. Now let's talk about that 2. The 2, given as the second argument, specified columns. A 1 would give us row information. So if I was to use a 1 instead of a 2 and still use the median, now what I'm getting is something that doesn't make sense at all. I'm getting the median for every row. So I have 200 rows, so the first row has a median of 41. Well, think about what that is. That's the median across female, school type, school program, the test scores, etc. That doesn't make any sense. But in some cases, your rows might be set up in a way that it does make sense. So it's good to know that you have a 1 for rows, 2 for columns. The lapply function, another of the apply family, the lapply is designed to work on list. We've seen the lapply before. But it will also work for data frames because a data frame is a list of vectors of equal length. Since it expects to apply the functions to the elements of a list, we don't need to specify whether to use columns or rows. It's only going to do this for a column because in a data frame, our columns are the list elements. And the way you get the data back is as a list, as you see here. So it thinks that you're giving it a list. It's going to give elements back in a list. Not quite as neat, but remember that lapply will work even for general lists, not just for equal length vectors like we have in data frames. So if I now obtain the lapply median and then look at the class of it after I store it, you'll see that the class is a list, which we kind of could see up here because of those dollar signs before each of our variables. If I want a vector instead, I can use sapply. This is like using apply, except that it will work with a list as well. So when we have a data frame, we might as well use apply. But if you have a list in which you have on equal length for each element of the list, you can use sapply. It assumes a list. We have no need to specify that we want to do this to columns. We get back a vector, and we did it without having, like we had up in apply, we had to indicate whether we wanted rows or columns with our 2. in sapply, right here, in sapply, we didn't need the 1 or a 2. It assumes we're going to use the columns. We can dig deeper and break the analysis into pieces with tapply. So apply is an entire family. And tapply will break this into pieces. Let's suppose that we want medians for reading by SES. So the first argument tells us what vector we want the median for. The second one tells us how to group it. And the third tells us what functions to use. In this case, of course, I'm using median. And so now you have the medians for low, middle, and high SES. And you can see that the reading scores actually go up with SES. You can also use the list argument right here in the middle for tapply to do this based upon more than one variable. So now what I'm getting is I'm getting by the 2 school types, 1 is public, 2 is private, and for low, medium, and high SES, all broken down. Finally, let me show you a function you should avoid, but I want you to be aware that it exists, so when you hear about it, you'll know I should not use this because you're going to be tempted, and I'll show you here why you're going to be tempted to use it. It's the attach function. So let's attach my data. Let me start again by putting my data here so we can see what we're dealing with. There's my data. I'm going to attach my data. Oh, this looks fun now. I don't have to say my data with the $ extraction operator to get first name. I can just say first name, and there's the first names. Here, if I want first names in the 3rd and 4th rows, I can just do it like this, and there's the first name in the 3rd and 4th rows. I can do columbines of first name with the score and now get the mean of the score. Notice that it's so nice and neat because we're not having to use my data every time because we've attached it. I'm going to show you now why we should avoid this, even though it looks tempting. I'm going to first go ahead and show you how to detach. We detach the data using the detach. And now, if I were to ask for, say, first name, now it tells me it's not found because I have to say it like this. Now let's create a vector called score, and let's calculate the mean. So here's a little vector. Score is going to have 125, 315, 282, and the mean of those is 240.7. Let's reattach my data and calculate the mean of the score in my data. So let's attach my data. Let's look at first name. There we are. We're now able to do this so simply. And we also have a variable called score. Let's get the mean of the score. Uh-oh, it did not give us the mean of the score for my data. It gave us the mean of the score that we already had. Why? Because when you try to attach it, you now try to create a variable called score when one already existed. We already have a score variable. So whereas we did not already have a first name, so that works fine, we cannot get the score for my data unless we do it like this, unless we actually list out in my data. In fact, if you go back here and look when we attached, R even warned you that it was going to mask the score within my data. This can lead to serious problems if you're analyzing data to prepare a manuscript. If you look at the Google R style manual as one example, Google tells employees not to use attach. Many other style guides say the same thing. We won't either. I recommend you put in your style guide, do not use attach. So we need to end this potentially destructive attachment. But it seems so nice. Are there any alternatives? Yes, there are alternatives. We already know One alternative is to directly reference the variable using the extraction operator. I know it's a little bit longer to type, but it's not as dangerous. Here's another option that can be used for many functions. Many functions will allow you to add a data argument at the end so that you don't have to keep typing the name of the data frame when you're naming the columns. Here's an example. The linear model function will model write as a function of read for the data frame HSB2, and that works just fine. A third method is to use the with function. This says, with HSB2, do the mean of reading. So the with function will work. Now, for getting the mean, it might be just as easy to put mean HSB2 $read, but there are some other times that you'll come across where the with will actually make it more readable and less to type. Here's with HSB2, do a linear model of write and read. So we can actually have a function of linear model that calls for arguments. We did that actually up here with mean. It called for the argument read. So here are some of the common functions that we looked at to use with data frames. We can transpose a data frame with the transpose T function. We can apply a function to data frame columns with the aggregate function. And then we have a whole family, the apply family, that can also apply a function across data frame columns. Each of these work a little bit differently. Apply will return a vector of function results for either columns or rows, but we have to specify which, and it can only be used with the data frame. lapply will work with any kind of list, including data frames, and will return a list of function results for columns. sapply will also work with either list or data frames. So for data frames, this will return a vector of function results for the columns. And tapply can be used to apply a function to a subset within a data frame. Attach can simplify use of column names in a data frame, but should be avoided. There are alternatives to using attach: direct reference of a column with the $ operator, using a data argument with the functions that allow for that, and using the with function.